Hello students, today in this class we are going to learn about the branch of physics that deals with the measurement of heat, and that is known as calorimetry. Alright, so here we learn about the measurement of heat. Now, since we are talking about heat, so let's understand the basic concept of heat. All right. So that is a glass full of hot water, and when we touch that glass, we feel hot. Similarly, when we touch a glass full of ice, we feel cold. So what's the reason? The reason is very simple. It is because of the gain or loss of energy. In the first case, that means when we touch a hot glass, the heat from the glass flows to our hand, because in this case also the energy flows from higher temperature to a lower temperature. That's why the energy flows from the hot glass to our hand, and as we receive the energy, we feel the heat. That similarly, when we touch a glass full of ice, that ice will be at low temperature, most probably at 0 degrees Celsius, and our hand will be at higher temperature. So the energy in that case flows from our hand to the glass. So as we lose energy, we feel cold. Okay, so this type of energy which flows from higher temperature to a lower temperature, okay, that form of energy is known as heat. That's why we define heat as the form of energy which flows from hotter object to a colder object when the two objects are kept in contact with each other. Now let's see the units of heat. So as you know, when an object is heated, okay, when an object is heated, then its temperature rises, isn't it? Its temperature rises. Similarly, if we have 1 gram of water, okay, 1 gram of water, and if we have to increase its temperature by 1 degree Celsius, then we have to supply some amount of heat, isn't it? So whatever amount of heat that is needed to raise the temperature of 1 gram of water through 1 degree Celsius, that is known as calorie, and that is the CGS unit of heat, okay, and that is called calorie. So this is defined as the amount of heat required to raise the temperature of 1 gram of water through 1 degree Celsius. All right. But here, one thing you have to understand is this 1 degree Celsius means any 1 degree Celsius rise in temperature, isn't it? Like from 5 degrees Celsius to 6 degrees Celsius, or from 10 degrees Celsius to 11 degree Celsius, okay. But as we see these two cases, okay, so we'll find that the amount of heat required in these two cases will be slightly different. It will not be the same amount of heat, okay. So for 1 degree Celsius rise in temperature, okay, the amount of heat will be slightly different, okay. So in that case, that 1 degree Celsius is taken from 14.5 degrees Celsius to 15.5 degree Celsius. All right, that's why we now define calorie as the amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degree Celsius. The second unit of heat is the SI unit, and this is called joule. The definition of joule is very similar to the definition of calorie. Okay, so you just have to bear in mind this is the SI unit. Okay, so in this case we take 1 kg of water. Okay, now again, to raise its temperature through 1 degree Celsius, okay, you know, to raise the temperature of 1 kg of water through 1 degree Celsius, we need some amount of heat, isn't it? So whatever heat is needed in this case, that amount of heat is known as joule. Okay, and as I said earlier, this 1 degree Celsius is not any 1 degree rise in temperature. Okay, it is from 14.5 to 15.5. all right, so that's why we define joule, okay, as the amount of heat required to raise the temperature of 1 kg of water from 14.5 degrees Celsius to 15.5 degree Celsius. So these two are the units of heat and their relation. Very important for you to remember. 1 calorie is equal to 4.2 joule. Now look at that glass containing a hot liquid. Now how to express the hotness of the liquid, isn't it? Now that can be done very easily with the help of numbers. For instance, suppose if I say 12 degree Celsius, means it is warm only, isn't it? But if I say 120 degrees Celsius, it means very hot. So these numbers are used in order to express the hotness of a body, isn't it? So these numbers are called temperature. Let A be an object at 50 degrees Celsius and B be another object at 110 degrees Celsius. When these two bodies are brought in contact, then there will be transfer of energy. That means there will be transfer or flow of heat, isn't it? Now, will the heat flow from B to A or A to B? It will flow from B to A. Why is that so? Because heat always flows from higher value of the temperature to the lower value of the temperature, isn't it? So it is the temperature that decides the flow of heat from one object to another object. That's why we define temperature as the degree of hotness of a body which decides the flow of heat from one object to another object when the two objects are brought in contact with each other. Like all the physical quantities, temperature also has its units. The commonly used unit, which you must have used earlier also, that is Celsius. And it is also known as centigrade. Okay, like suppose if this is the Celsius scale, okay, the temperature, you must be knowing the temperature at which water freezes into ice, no? And what's the temperature? That temperature is 0 degree Celsius. And at what temperature water boils at normal pressure? It is 100 degree Celsius. So this temperature at which pure water freezes into ice at normal pressure, this temperature is known as lower fixed point. And this temperature at which pure water boils under normal pressure is known as upper fixed point. So this way we express the temperature in degree Celsius or degree centigrade. Alright. Now look at this. In this particular scale, the temperature starts with 0 degrees Celsius, isn't it? But in another scale, the temperature does not start at 0. Okay, it starts, this is 0 degrees Celsius. Okay, it goes well below 0 degrees Celsius up to minus 273 degree Celsius. Okay, now in this scale starts from 0 degrees Celsius. Okay, but this scale of temperature starts from minus 273 degree Celsius. Okay, so this scale of temperature, okay, is known as Kelvin or absolute or Kelvin scale of temperature. Okay, and this minus 273 degree Celsius is taken to be 0 Kelvin. So in this case, we don't write degree, we just write that value and K for Kelvin. Okay, so this value, okay, minus 273 is 0 Kelvin. So it goes on and on like this. 1, 2, 3, 4, 5, 6, 7, 8. All these are Kelvin. Okay, so think of the answer. Okay, be ready with the answer. As we reach this point, 0 degree Celsius, that means this 0 degree Celsius mark, what will be the Kelvin temperature out here? The answer is very simple. Okay, so how many divisions are there below 0 degree Celsius? Minus 273 means 273. There are 1, 2, 3, 4, that means 273 divisions below, isn't it? So to come from here to here, you have to move how many divisions? 273. So this much is how much? 273, isn't it? That's why from here to here, if this is 0 Kelvin, this is 273 Kelvin. Okay, so it goes on and on like this. So this scale of temperature is called Kelvin, okay, or absolute. And it always starts from 0 Kelvin. And another very interesting and important thing for you to remember is this thing. When the temperature of any mass of a gas, okay, is reduced to 0 Kelvin or minus 273 degree Celsius, the volume of that gas will become 0. Okay, why that happens? Because we know it from Charles' law that as the temperature decreases, volume also decreases. That's why as the temperature goes on decreasing, volume also goes on decreasing, and ultimately volume becomes 0 at this point, at this temperature. Okay, that's why this is called absolute 0. This temperature is also known as absolute 0. Okay, so at this temperature, both the pressure and volume will become 0. Okay, now can volume and pressure be negative? No, volume and pressure cannot be negative. That's why temperature below this is not possible, because if we go below this temperature, okay, the volume from 0 has to decrease, that means has to become negative, which is not possible. That's why any temperature below 0 Kelvin or minus 273 degrees Celsius is not possible. Now let's see the relation between Celsius and Kelvin scale of temperature. So you see this temperature is 0 degrees Celsius, but this temperature is in this Kelvin is 273 Kelvin, but they mean the same temperature, only the readings are different. Okay, this is 0 here, this is 273, but they mean the same temperature. It's like saying 1 hour and 60 minutes. All right, so 0 here becomes 273, isn't it? So 1 here, 1 degree Celsius means here it has to be 1 more than this, means 274 Kelvin, isn't it? So it goes on like this. So what is done in this case? Whatever is the Celsius temperature, okay, then whatever is the temperature in Celsius scale, we add this much temperature. Okay, so this much is 1, from here to here it's 1, isn't it? So to get the reading in this particular scale, we have to start counting not from this point but from this point, isn't it? From here to here it is 1 division. So how many divisions you have to go below up to 0 Kelvin? It's 273. Okay, that's why whatever is the Celsius temperature, okay, to that we have to add 273 to get the absolute temperature or Kelvin temperature. Okay, so next topic is, so we write the relation like this: T is equal to small t plus 273. So this is the formula where capital T is the temperature in Kelvin scale and small t is the temperature in Celsius scale. Okay, so this is the formula. So to convert Celsius to Kelvin, okay, we have to add 273 to that particular temperature. Okay, now this is very easy to understand and very easy to forget also. Okay, but if you will not forget this if you have understood the concept behind this. Okay, so Celsius starts from this only, whereas Kelvin starts from this. That's why you have to add this much to Celsius. That means this much means 273. Okay, now after this, let's take some numericals based on this particular formula. Now the question is, express the following temperatures in Kelvin scale. Now the first question is, let's say 27 degree Celsius. T is 27 degrees Celsius, temperature in Celsius. Okay, and capital T we have to find out, and the formula is T plus 273. So T is 27 plus 273. So when we add these two, 7 plus 3 is 10, 7, 8, 9, 10, 2 and 1, 3. This is Kelvin. Okay, so don't say that which one is greater. Okay, they mean the same temperature, only the numbers are different. Number 2, let's say the temperature which you are given is 0 degrees Celsius. Okay, so we need to, if you need to convert that in Kelvin, we do the same thing. Okay, first we write the formula. So this is T plus 273. So T is 0 plus 273 is 273 Kelvin. So this way we solve the numericals, okay, or express the temperature in Kelvin. Now the last one. In question number 3, I'm taking the temperature in Celsius to be minus 3 degrees Celsius. And sometimes in winter, we experience this kind of temperature, no? As we know, this plus 273, T here is minus 3 plus 273. Plus and minus, you have to subtract, isn't it? So 273 minus 3 is 270, and when you subtract, you have to put the sign, the bigger number. There's the bigger number, sign is plus. 270 Kelvin. So this way we express temperature, okay, in Kelvin scale. Now the next question is, express the following temperatures in Celsius scale. So number one, suppose we have 127 Kelvin. Okay, 127 Kelvin. Now in this case we do just the opposite. Okay, so in the previous case we added 273, isn't it? But in this case we have to subtract. Okay, or we can use the formula also. So this is the value of T, capital T, no? And small t is what you have to find out. And what is the formula? Capital T is T plus 273. And when we transpose it to this side, plus becomes minus, no? Therefore, small t will be this minus T minus 273. Alright, so to express the temperature in Kelvin, you have to add. To express the temperature in Celsius, you have to subtract. T is how much? 127 minus 273. We need to subtract, no? Now, so 13 you have to carry, no? 13 minus 7 is 6. This is 6 left out, no? 6 minus 2 is 4. And 2 minus 1 is 1, and sign of the bigger number is minus this much degree Celsius. So this way we do the conversion from Kelvin to Celsius. Okay, so you just have to bear in mind that the value of a certain temperature in Kelvin will be more, and that temperature in Celsius will be less. Okay, it will be less. Okay, so that's why if you remember that, it will be easier for you to do the conversion in the exam also. Okay, otherwise you'll easily get confused. Okay, so the temperature in Kelvin is always higher than the temperature in Celsius. That's why to express the temperature in Kelvin, you have to add 273, and to express the temperature in Celsius, you have to subtract 273.